We are going to look at a partial neutralization of a strong acid and strong base. So in our titration, we did a neutralization where at the end point, moles of acid equals the moles of base, or moles of H plus equaled moles of OH minus, so therefore the pH was 7. But what if you had an unequal moles of acid or base? Could you still figure out that pH? Yes, and we're going to take a look at how to do that. So we have a problem where we have 250 milliliters of 0.10 molar HCl, and we're going to combine that with 50 milliliters of 0.20 molar NaOH. And we're going to find the H plus, COH minus, and then the pH of that system. So first off is when we do a neutralization, we're not necessarily comparing molarity or liters, we're comparing that combination, which would be moles. So let's find the moles of HCl. We do that by taking 0.250 liters, multiplying it by 0.10 moles per liter, and I get 0.025 moles of HCl. I'm going to do the same thing except with the moles of NaOH, or the molarity in the liters of NaOH, and I'm going to take 0.050 liters times 0.20 moles per liter, and I get 0.010 moles of NaOH. So what is going to happen is the H plus from HCl and the OH minus from NaOH are going to cancel out in a 1-to-1 fashion, but what I'm going to have is 0.015 moles excess HCl. In order to find my concentration, I'm going to take that 0.015 moles, which is the difference between those two. And remember, HCl is a strong acid, so it completely splits up or dissociates. So I'm going to take that 0.015 moles and divide it by the total number of liters in the solution at this point, which is the 250 milliliters I started with, and all of the acid that I started with, and the 50 milliliters of the NaOH. So what I'm going to do is take that 0.015 moles of excess, divide it by the sum of the 250 milliliters and 50 milliliters, which is 300 milliliters or 0.3 liters, and I get 0.050 molar. That is the H plus concentration. With that much extra H plus, I can figure out OH minus. With that extra H plus, it's going to drive the OH minus concentration lower. I can just say Kw over H plus. I do that 1 times 10 to the negative 14th over 0.050, and I have 2.0 times 10 to the negative 13th molar. Okay, if I know the H plus concentration, I can figure out the pH. It's just a negative log of H plus, which is a negative log of 0.050, which would be 1.30. So even though a lot of this cancels out 1 per 1, I have an excess acid. That's going to make the pH actually very low, or it's going to be still quite acidic because of that extra acid. One thing to note is something about significant figures here. Typically we'd look at this and say, oh, this has 3 figures. But when you do pH, the 1 is really just indicating times 10 to whatever power. So the number in front indicates times 10 to whatever power. The 0.30 are the 2 significant figures here. That corresponds to 0.050, the 2 significant figures in my concentration. If I subtracted from 14, I would get a POH of 12.70, which would also show 2 significant figures. It's coming from the same measurements. Again, the 12 is just telling me times 10 to whatever power, so that's where that comes from. Take a look at this, and you can use this to solve problems 1 through 5 on your challenge problems.